Hello everybody, ito po ang inyong lingkod, Yuritech at your service.
I'd like to share something with you, fellow technicians, that will definitely be helpful for anyone involved in hardware repair, whether you're a beginner or already experienced. As cell phone technicians, we all know that one of the most difficult issues to diagnose and fix is network-related problems, commonly known as no signal. This challenge becomes even tougher when dealing with iPhone models, as almost half of the sandwich board in the newer iPhone models is dedicated to the network system. But thanks to this tool, we can now diagnose network issues even before opening up the unit. Yes, you heard that right. This tool is small and inexpensive, but the convenience and assistance it provides in our work are far greater than its size suggests. It truly lives up to the saying, small but terrible. In addition to being affordable and compact, it's also user-friendly. It works alongside a multimeter and, of course, a schematic diagram, tools that every technician doing hardware repairs or learning microsoldering is likely to already have. I have here an iPhone 14 Plus with a no power issue. After I managed to power it on, it had no signal. Using the SIM checker, I found that the problem was in the baseband circuit, and I was able to diagnose it without needing to open or disassemble the iPhone 14 Plus's sandwich board. To use the SIM checker, the iPhone must be powered on. Insert the SIM card into the SIM checker. Use the SIM one slot if the phone is single SIM, or both slots if it's dual SIM. Then, place the black, negative probe on the ground, and use the red, positive probe to test each test point, VCC, RST, CLK, and data, one by one. This allows us to determine if there's an issue with the SIM slot, baseband power IC, or the baseband IC itself. How are we able to test all that? Simple. The VCC line is connected to the baseband PMU, while the CLK and other lines are connected to the baseband IC, and all test points are connected to the SIM slot. So in one go, we're able to test 3 major components without even disassembling the unit. And as a technician, that's a big advantage. It gives us an early idea of whether the issue is repairable, if we have the necessary parts, and whether it's within our capability to fix it. All of these questions can be answered quickly, just by diagnosing with the SIM checker. Earlier, we looked at an iPhone 14 Plus with no signal. Now let me show you a reading using the SIM checker on an iPhone 12 that does have a signal, so we can compare and understand the difference between the two. What I noticed is that on the iPhone 14 Plus, the voltage fluctuates. It disappears and reappears along with the lights. But on the iPhone 12, the voltage remains steady at 1.8 volts on the VCC, RST, and data lines. This suggests there may be an issue with the baseband PMU on the iPhone 14 Plus, or possibly a short circuit on the 1.8V line. In short, I may need to replace the baseband PMU or reball the baseband IC. Thank you very much for watching, and I hope you've learned something from this video. Once again, I am your technician Yuritech, at your service. For those interested in purchasing the SIM checker I used, I'll place the link in the comments section where I ordered it.